So word problems. So basically, I'll explain to you what just happened. Like why are we here, right? The book. Yeah. Yeah. The way the book is set up, or the way this unit is actually set up, it might be two, right? I don't know. There's more. It jumps right into word problems. Like there's no review of IPR. There is no like let's just deal with inequalities and then do word problems. It jumps right into word problems. And I found that students struggle big time because it's so much at once, right? Word problems, how to graph an inequality, right? You kind of lose it. So I've basically warmed you up to what's coming your way, but now we need to kind of take a step back and start with word problems and how do we deal with them. So here we go. When given a word problem, you will have to read and interpret the question, right? In order to produce inequalities, right, for any restrictions present. If you think about it, inequalities actually are restrictions. Like it's saying you can have up to this much, or you have to have a quantity that's greater than or equal to this much. So it's a bunch of restrictions put on the situation, right? And when you put them all together, you end up saying, hey, if there's a solution, it'd be in this area that is not shaded, right? So things to keep in mind. The whole time we're working through, the whole time we work through word problems, you always have to keep this in mind. Okay, so the first one is type of data. Like what kind of data are we looking for? And there are two main, right? There's discrete and only exists in whole quantities. Sorry, there you go. Only exist in whole quantities. Example, right? Coins, people, cans, etc. So certain items, you cannot have part of it, right? You can't go to Rona and buy 0.67 of a can, right? So we need to round, right? So that what this means is that you'll have to round POIs, right? You'll have to round POI. So example, if you have 6.917, right? If that is the actual point of intersection you got, you will write it down as is, but then next to it you'll have to round. So this will be 77, right? Because if we're dealing with discrete data, you need to have whole quantities. And you know what? Rounding up or down, you just go by the number. If it's right 0.5 and greater, then you round up. If it's less than that, round down. The other type is continuous. You should remember this from IPR somewhat. exists as a decimal / fraction In other words, you can have partial quantities. So the examples here would be time, right, distance, temperature, money, and so forth. So if you have a decimal, no problem, right? Use POI as is. So I'm going to highlight that. And so if your variable represents hours, then just use them as is, right? Don't round. If we figure out, I would say most of the time you do round. Most of the time we round for word problems. Number of hot dogs and burgers, right? How many can you produce? Cars, right? And so forth. Second element I want you to keep in mind is almost all cases involve data that cannot be negative. Therefore, your graph will only take place in quadrant 1. And I will actually give you a pretty like a visual representation of that. So if you have a ruler, go for it. If not, that's okay. Just make two axes like this, right? X and Y. This one has a context. So at the top, I'm going to go context. Sometimes you'll hear the word contextual, right? When there's a text associated. So we have quadrant 1, quadrant 2, quadrant 3, and quadrant 4. And I'm going to use two different colors here, red and blue. If you have it, great. If not, not a big deal. So let's say that the red one goes somewhat like this. Try to get it about the same as I am in terms of where it crosses. It's close to the origin here. And we will make them cross right there. Both of them will kind of share this point in common. So we'll sketch it like this. And I'm going to shade as follows. My solution region is going to be right here. This whole thing, there's a wedge there. So I'll be shading below the red one and above the blue one. right? So my solution is that wedge right there. No context, right? Underneath I write no context, therefore only one POI here. Okay. No context. Right next door, right here, we're gonna say, okay, let's assume this was actually involving a word problem. I'm only gonna stick with quadrant 1. Watch, I'm only gonna try to stick with the first quadrant here. This is my X and the Y. And I'm gonna copy, like almost imagine, go over to your original there, and the red one just goes right here. So I'm just gonna make a little crossing there. Right? This is, I'm always zooming in a little bit, but this little stretch that shows up in quadrant 1 is right here now. And the blue one, they share a point here, but the blue one goes there. And I'm going to repeat my shading. This is my solution region here, still. So the solution hasn't changed, except for I'm now bound to the first quadrant. So just make sure you don't go out of quadrant 1. This does have a context. So underneath, just write down context word problem. It has 3 POIs. And why is that? Watch this. Just go back to your graph and make a big point right there, and right there. Because you're bound to the first quadrant. Now the X and the Y axis also almost act as lines. Okay? And I will say this because X and Y axes act as lines. So you're basically saying that all the X values have to be greater than or equal to 0, and all the Y values have to be greater than or equal to 0. It's like a little bit of a nuisance, but if you get used to writing that every time, word problems, right? You can't have -1 of a can, right? Or -3 people. Can't have that. Or -5 hot dogs, right? You can't have that. So we're assuming then, right? So do not extend your lines ever past quadrant 1. Okay? Don't have arrowheads, it stops, right? No arrowheads anywhere when it's a word problem. So today we're not actually going to solve a word problem. I'm just going to get you all set up so that tomorrow we can start with it. Backside. Turning words into inequalities. So let's try to explore this a little bit. Let X be the number of people and let Y be the number of pets. So these are a little bit out of context, but it'll give you enough to write an inequality. So what if there you saw a statement that you can have no more. Let's write them all down first. No more than 40 people. And I will answer it right next to it, so you don't need to leave a lot of space in between. What if there's a sign that says at least 10 people? Room can hold. Room can hold 50 pets. A committee needs a minimum. I'm throwing around a lot of different words for a reason. A minimum of 35 people. Sorry, I'm running out of space. I'm just going to go like that. Stadium has a capacity, that's also a key word there, a capacity of 30,000 people. A specific vet can see up to 24 pets. A facility can hold 100 people, and this is a longer one, pets combined. Let's leave it at that for now. So let's go back up here. Zoom in just a little bit more. Good. Let's write inequalities, and this is just getting you started and warmed up. Okay. So if a room or a place can have no more than 40 people, and in this case, X represents our number of people. So we need to start our statement with number of people. And so the number of people has to be no more than 40. So that means that it has to be less than or equal to 40, right? This statement right here, the inequality, is saying that the number of people has to be less than, it can be equal to, right? It's implied that you can have up to 40, but no more than 40. So this is how you would write that statement. At least 10 people. So we're talking people again. And at least means 10 or more, right? So then you would have to say that the number of people has to be greater than or equal to 10. A room can hold 50 pets. Our variables are defined that y it represents the number of pets. So we'll start with y, And so it can hold 50 pets, meaning up to, right? Holding, if something can hold 50 pets, is like that's the maximum that it can hold. So it has, the number of pets would have to be less than or equal to 50. That's what this is saying. The number of pets has to be less than or equal to 50. A committee needs a minimum of 35 people. So we're talking people, and the number of people has to be greater than or equal to 35. Let's keep going. A stadium has a capacity of 30,000 people. So we're talking people again. Capacity means has the ability to have this many people, right? So it's almost like up to. If you see capacity, it's like this is how much it can. So what we need to write is that the number of people has to be less than or equal to 30,000. That's what this statement is saying, right? You can have up to 30,000 people, but no more. So read it from left to right. Okay. A vet can see up to 24 pets. So we're talking pets here. So what has to be the case? Well, if you can have up to 24, you need to write it like this. Right? The number of pets has to be less than or equal to 24. Most of them are or equal to, by the way. Most of our questions are going to have that, so you don't have to worry about dashed lines as much. I think there's one example maybe that has dashed. Next, this one is a little tricky, so we're upping it, right? A facility can hold 100 people and pets combined. Oh, okay. So you're basically what it's saying that the number of people and the number of pets in that facility has to be less than or equal to 100. So that's when we're introducing both variables into our inequality. How about this one? This is a different question, okay? The sum of two numbers is less than 20. If you saw a statement like that, the sum of two numbers is less than 20. Well, the sum should tell you, right? I forgot something here. We have to say let x be first number and let y be the second number. You don't have to use x and y, but I tend to do that quite often. So the sum of two numbers is less than 20. It is very specific here. It's saying this sum is less than 20. There's no equal to. It has to be less than 20. So there's a restriction. You can add a bunch of numbers. You can pick 2 and 3, 4 and 5, but it has to be less than 20. Okay. I think I'll leave it at that for examples here. So here is the next piece. So let's just write down the steps so we can dive into more, okay? Steps to interpret and graph word problems, okay? And these steps are my suggestion to you. It makes it, you will be more successful if you follow them. Okay, so the first step is introduce variables. And by that I mean let x be, first variable, y be second variable. You have to be specific. Is it, sometimes students just say, let x be people. Write down the number of people, right? Let y be the number of hot dogs, right? Or something like that. Secondly, state the implicit constraint / restrictions. And this one is almost a no-brainer, except for some students, because they rush so much, they forget that. You gotta say that x is greater than or equal to 0. Have like squiggly brackets like that. Y is greater than or equal to 0. So you're basically saying only positive values apply. And implicit means that we don't have to say it. The question doesn't have to say it. We're just assuming that this is the case. Another way to make this faster, you can just say x comma y is greater than or equal to 0. So it's your choice. Do you want to state them both separately, or do you want to have them both together? But make sure you know which way it's pointing. Some students put, like, flip this sign, x and y less than or equal to 0. That's wrong. And you don't want to lose marks because of that. 3, write the inequalities. Present it. There should be an inequality for each restriction. For each restriction mentioned. Okay? Let me focus here a bit. I will say this. 4, graph inequality. We're almost done. After this, there's just one more. Graph inequalities in step 3. Okay? But remember, to only graph quadrant 1. Your calculator shows all 4 quadrants, but you need to stick to quadrant 1. Do not extend lines. Because that will make you lose half marks, okay? 5, state the coordinates. State all POIs I will say this, round if data is discrete. And that's it for today. No homework. How's that? The only thing I would advise is make sure you review how to graph and all that.